Hello everybody, welcome back to my channel. So this session is especially for one of the important protocols. So in these sessions, we are going to discuss about UDP. Okay, it is very widely used. If you are working in any field, guys, in network security engineer, cloud security engineer, cyber security engineer, even in developing field, and so you should be aware about the protocol like UDP, TCP. It is very important if you want to understand the network actual how it works. People generally type something on the google.com or like on google like facebook.com, youtube.com, other Instagram. But what the process in the we can backend, mostly people's not aware about it, right? So we'll try to cover this session will not much long, guys. This session will try to cover UDP in very short. Okay, so before I starting this slide, let me show something, and it is very interesting, guys. I open three tabs: google.coms. I open three tabs. Okay. Let's consider this tab is want to communicate with Google DNS, for example, DNS, or we can consider it. I'm just considering 8.8.8.8.8. Maybe it is requesting something, for example, cat is the page. It is requesting something from the application server, web server. We can say destination server. Okay. Maybe this we can consider this source is this tab source is 192 168 1.1, right? When this destination will send reply to this source, what is the source here? 88. And what are destinations? 192 168 1.1. Okay, but the similar types of requests coming from other tab also. So how destination server is going to be recognized? Okay, I need to send this traffic to this tab or this tab or this tab. So for avoiding or resolving this purpose, guys, we use, or we can say like port concept developed. We can say like maybe TCP or UDP. Okay. So after IP header, our transport layer, we can say like headers, we can say like TCP or UDP header added after IP header. Okay. So for example, this is IP header, and then here it will one header will be added where it will mention source port and destination port, guys. Okay. So in source port is basically random generated port, and destination ports for the server for the application which is registered where you want to communicate. For example, if you want to communicate on the DNS Google DNS service, maybe you can use destination port 53, or maybe if it's HTTP server, maybe we are using destination port as a 80. So here we can use destination ports 80. Source port is randomly generated port, and here will be mentioned like source IP, and here will be mentioned as a destination IP. Okay. So when destination is sending reply to the source, it is going to recognize with the help of source port, which is generated randomly. And destination port basically is registered port, maybe HTTP, telnet 23, or maybe HTTPS 443. So our destination port is always registered port. Okay, but source port is randomly generated port. Okay, so I hope guys you understand why you use port, why you use port. Okay, and why UDP and TCP is very important in any packets, in any network packets. Okay, let's move on our slide now. Okay, so UDP is guys connectionless. It is not connection oriented. There is no any guarantee of your packets. Like whatever I'm sending, it will get 100% reply back as acknowledged. It is not. Okay. And UDP header, I mentioned it is placed after the IP header. I mentioned earlier also. And UDP is basically used, guys, by time sensitive applications intolerant of delay. Okay, so UDP basically used in time sensitive applications. At the moment, I am teaching you with the help of Zoom application. Maybe I'm saying I'm sending hello to you, and maybe you did not heard that part, right? So it is not going to send again. It is not going to retransmit that packets. It is not going to retransmit that message. Okay, if it is going to retransmit, maybe it will create some we can say like mixed things. It is not good because same things coming again and again. We are in a meeting, right? If you are sending hello, maybe someone not listens because TCP work as a connection oriented. Every packet should acknowledge in case of TCP, but not in UDP. So for these types of applications, for these types of sensitive time applications, we use UDP, guys. Okay. So this is the header of UDP. So first header is like Ethernet header, then our IP headers, then our layer 4 header, that is transport layer, we can say, where UDP source port number is mentioned, UDP destination port number is mentioned, and it contains some length plus data and UDP checksum, and then payload. Payload in case of like in our case, whatever I mentioned, it is HTTP. HTTP, right? Okay. Then we'll try to understand like transport layer port numbers, guys. Okay. So every TCP and UDP segment, guys, every TCP and UDP segment datagram has a source and destination ports. So whatever session generated, every session, or you can say every segment has one source and destination port. Okay. On the basis of that, it is going to recognize like whatever communication happening. I need to send to which people, to whom I need to send. Okay. So I mentioned earlier like destination port typically a well-known and register applications port. Okay. And source port typically we can say like randomly generated, but destination port is not randomly generated. So please keep in mind. Okay. Then guys, TCP UDP ports separated into three ranges by IAN, INA. So try to do Googles and try to understand what is INA. So port number 0 to 1023 guys are used for common and well-known services. Okay. And port number 1024 to 4915 are the registered ports used for INA registered services. Okay. And ports number 49152 to 6553, 65535 are dynamic ports, and it is not registered. It can be used as per any purpose. Okay. And may be used for any purpose. So you should be aware about three categories, three ranges, 0 to 123. These are used for well-known services. 124 to 49151 used for INAV registered services. And port number 49152 65535 65535 are dynamic ports, and it is designated for any specific service and may be used for any purpose. Okay. Last, guys, before closing this slide, it is also important to understand like how ports number works. Okay. So please be you know try to okay, so we try to understand the parts like how ports number works, and please try to concentrate it. Okay. For example, this is your laptop and this is telnet server. Okay. So the telnet daemon has been started on me. I need to listen to inbound requests on TCP port 23. What is the meaning, guys? So this is the server where services 23 is enabled, and this server is telling I can listen on the services 23 for inbound request. Okay. So it is saying like I need to listen the inbound request on TCP port 23. So if any traffic coming to me on port 23, I'm going to listen that. So that is called inbound or inbound request, guys. Okay. This is the client. This is your laptop. We can consider. And this laptop is saying, I need to request a telnet connection to this server, and I'm going to select on random source port that is 50,000 for these sessions. Okay. So see how port number works and how it is important. Your doubt will be clear here, guys. Okay. It is telling this is my source port. I want to connect on the destination port 23. This is my source, and I want to connect on this destination IP. So here it is mentioned random source port. Okay. So when this server is going to send reply back to the that source, it is using source port as its on ports, destination port this client port, whatever randomly generated, and source IP its on IP, destination IP is client IP. Okay. So with the help of source IP, it is going to recognize, okay, I need to send this request to this PC, this client. Maybe multiple people sitting here and sending multiple requests to this telnet server, we can say. So how it is going to recognize? It is going to recognize on the basis of source port, where maybe consider other like 50,001, 50,002. So accordingly, this server is going to send the reply to 2, or we can say like 50,001. So this is how port numbers works. Okay. So I hope you guys understand about the UDP and why it's play vital roles and why we use it. And one more thing before closing this session, I want to show guys, if you want to go some deep dive, just open Google and search UDP packet capture cloud source, and we can see there is one UDP pkf file, and we can read that file. Okay. For example, this is the user datagram protocols. We can say like our layer 4 transport layer. Here source port is there, destination port is there, here checksum is there, timestamps is there, UDP payload is there. So we can read one by one here also. Okay. So I hope you guys understand the work case and how UDP works and about UDP. So if you like this session, I'm pretty much sure this is going to be useful for everybody, even for non-technical area, even on different area. So if you really like, please like this session, subscribe, share as much as possible. Let's meet on the next session, guys. Thank you very much for your times.